any signal, each one living in its own slice of the spectrum. Frequency division multiplexing gives every channel its own frequency bedroom. No time sharing, no taking turns. All channels transmit simultaneously. FDM is the foundation of radio, cable TV, and telephone history. Your own lane, a dedicated frequency band. Each signal stays in its slice. That is the plan. Guard bands keep the channels from bleeding into each other. FDM lets every signal run without disturbing its brother. Simultaneous transmission, all channels fire at once. Your own lane, frequency division never fronts. The available bandwidth of the medium is divided into subbands. Each subband is a channel assigned to one signal and its demands. The signal is modulated onto a carrier frequency inside its band. AM, FM, or QM modulation, the technique depends on what is planned. A carrier wave is a pure sine wave at the center of the channel frequency. The data signal modulates the carrier, changing its amplitude or frequency. AM changes the amplitude, the height of the wave carries the information. FM changes the frequency, the rate of oscillation is the modulation. At the receiver, a bandpass filter extracts one channel from the full spectrum. It passes only the frequencies inside that channel's band, rejects the rest of them. Demodulation trims the carrier away, leaving only the original signal clean. Multiple receivers each tuned to a different channel. That is the FDM scheme. Your own lane, a dedicated frequency band. Each signal stays in its slice. That is the plan. Guard bands keep the channels from bleeding into each other. FDM lets every signal run without disturbing its brother. Simultaneous transmission, all channels fire at once. Your own lane, frequency division never fronts. Guard bands are empty frequency gaps between adjacent channels on the spectrum. They prevent interference from one channel bleeding into the next. A spectrum septum without guard bands, the edges of one channel overlap the next channel's band. Intermodulation distortion corrupts both signals. Guard bands take a stand. Guard bands waste spectrum, the empty space carries no data at all. The wider the guard band, the cleaner the separation, but efficiency will fall. FDM solve this with mathematically orthogonal subcarriers tightly packed. No guard band needed between subcarriers. Spectrum efficiency is max. Analog telephone used FDM to carry multiple calls on one wire in the past. POTS multiplex calls onto carrier systems, 12 calls per group held fast. AM radio uses FDM. Each station gets a 10 kHz channel in the AM band. 530 kHz to 1700 kHz, hundreds of stations each with their own land. FM radio uses FDM. Each station gets 200 kHz of spectrum to broadcast. 88 MHz, 208 MHz stereo audio and RDS data riding the mass. Cable television used analog FDM. Each TV channel on a 6 MHz slice. Channels 2 through 83 each modulated onto their carrier. Wasn't that nice? FDM is orthogonal frequency division multiplexing. FDM evolve. The orthogonality condition means subcarrier peaks align with neighbor nulls. Problem solved. Each subcarrier is spaced exactly 1 over the symbol duration apart in frequency. The nulls of each subcarrier hit the peaks of its neighbors. No interference, you see. This allows subcarriers to overlap in frequency without interfering at all. Spectral efficiency far exceeds classic FDM. A much tighter haul. Wi-Fi 802.11, a GN axiax, all use of DM for the physical layer. LTE and 5G and our use of DM. Every modern wireless standard is a player. DM is wavelength division multiplexing. FDM applied to fiber optic light. Each wavelength of light is a separate channel running through the same fiber tonight. CWDM course WDM spaces wavelengths 20 nm apart, up to 18 channels wide. TWDM dense WDM spaces wavelengths 0.8 nm apart, 80 or more channels inside. Terabits per second on one strand of glass. WDM made it possible to ride your own lane, a dedicated frequency band. Each signal stays in its slice. That is the plan. Guard bands keep the channels from bleeding into each other. FDM lets every signal run without frequency division never fronts. FDM assigns each signal a permanent frequency lane of its own. Guard bands separate the channels. Spectrum efficiency is the tone. FDM packs of carriers, orthogag in the lead, no guard band required. FDM takes FDM to fiber, terabits per second admired.